Hi guys, and welcome on my channel. Have you ever made a cable of cables in Blender? Maybe yes, but maybe using a profile only on the external part of the main cable. But what if you want to fill it with cables, avoiding overlapping and collision issues? Let's make a geometry nodes node to create a parametric cable of cables. Now I'm using a Blender version 3.5.1, and for this tutorial we are going to use some mathematical formulas to solve our problem. We are going to be able to manage this node through the main radius of the cable, or defining the radius of the sub cables. So for this, go to the plus button on the top part of the menu, General Geometry Nodes, Shift A to add what? A curve, not a mesh. In this case it's important because we need to use curves as cables. Press New to create a new Geometry Nodes modifier. And now for this purpose we need to know the relationship between the profile sub-cables and the big main cable. When you want to create a generic circle for the main cable with a resolution of 4 vertices, for example, and you often instantiate another circle on these 4 vertices, but you need to manage the radius of this circle all the time. And if you increase or decrease the main radius of the main cable, always need to redefine and remanage the small radius of the profile. And if you also increase the number of the circle of the profile, so the resolution of the main cable, you need to redefine and adjust the radius of the sub cable. So to avoid this need, you can use this easy example. You can see here we have 4 circles, one big circle for the main cable. Here we have the radius of the sub cable, the main radius of the main cable, and we want to have a node where we want to set the number of the cables instantiated and decide the way to modify in a dynamic way the radius of the main cable by the radius of the sub cable, or the opposite, so change in a dynamic way the radius of the sub cable based by the radius of the main cable if you need a specific diameter. So in this case we can see that this piece of this line is equal to the radius of the sub cable, and also this piece and this piece. Here we have a triangle, a rectangular triangle, and we know the little radius. We want to know the big radius of the main cable. As you can see, for this triangle I can get this r if I draw the angle here. This is alpha, for example, and we have r, that is this piece, okay, as this piece of line, and for this we know that r is equal to what? If this piece of line is a, for example, I have a to the power of 2 plus r to the power of 2 all square root. But we have a problem, we don't know a. We can't use this formula, but we know that in a rectangular triangle the opposite segment of this angle here, the small radius, is equal to r sine of the alpha. So to calculate this r we need this segment, and we need to multiply this segment for the sine of this angle here. And if we multiply by the cosine of the alpha we would obtain this, so a, but we don't need this. We can use only this formula. And now this is our variable that we need to know. We know the r, but we don't know the alpha. But alpha is very easy to calculate because if you look this configuration, and it works for all the configuration that you need, this alpha is equal to the entire round in degrees or radians divided by what? If I draw a line here to 45 degrees, near 45 degrees, okay, you can see these are 45 degrees, 45, 45, 45, etc. And the number of these partial angles is equal to the number of these segments. One here, one here, one here, one here, one here, etc. And this is always valid, this behavior. So in this case, knowing this information, we can calculate the alpha because we know the n as the number of subcables, and we can divide the 360 degrees by what? The number of the n cables So 1, 2, 3 and 4, and divide it again by 2 because I want only half part of the entire segment. So we have a total number of 8 segments. So in radians we have 2 multiplied by pi, the equivalent number of 360 degrees, divided by 2 multiplied by n. 2 and 2 go away and it remains pi divided by n. And going here we have r equal to big R sine of pi divided by n. And if we divide both of the sides by sine of the pi divided by n, in an easy way we move these to the other part, the bottom, we get big R equal to small r divided by sine of pi divided by n. And this is the main equation that we need. We only need this equation. And if we want to manage the big radius by the small radius, we need to use this formula. If we want to be able to manage the small radius by the big radius, we need to use this formula. And this is valid for all the number of cables you need here, without having here an overlapping or collision issues. So now let's make this little group node to use in our environment. So for this we can add a math operation, use a divide. We need a divide for this division from pi, and what a value. From this we need to calculate the sign. Then we need a divide where this is here, and in the upper side we need this variable, and we can add a value like this. We can select all these nodes, Ctrl G, create a group. Now that we have here, now that we have these, we can rename and change the type of this resolution value from 0 and rename these in the small radius from 0, and we have the big radius as the output, and we can link directly the small radius to reuse the same variable. I can add some dot here, move it a little bit. I can enable the snapping tool here, and this is the simple group to get the big radius from the resolution and the small radius. We can go out from this pressing tab. We can rename this group the get big radius. We can duplicate these and click here to create a distinct duplication of the group. Rename it in get small radius because we need to manage using this way or this way. It depends on your project. So now we need to go in this new get small radius to rename what the small radius in big radius, because we have this input here. And keep in mind we have here not a dividing operation but a multiplication. So we need to multiply the big radius by the sign of the division from pi and the resolution, and the output is the opposite. So small radius here and big radius here. Save the project, tab to exit from these two groups. Now that we have these groups, I suggest you to increase to 64 this resolution preview of your curve in your viewport to better manage the custom resolution that we need here in this layout. We can drop for a moment these values, move it here, and now we can add some attributes in the group input. One is the external cables counter. So this is an integer number. We can set, for example, 32 with a minimum value of 3, and we can link these two resolution here and here. At the same time, we need to add another integer number to manage the resolution of the cables itself. So I can set here cables resolution from 3, default 3, and for a better preview resolution, if I resample this curve by this number, Blender will divide each segment of this resolution by this resolution preview, okay, each segment by 64. And this is very important when you have a very long cable that we are going to tilt at some point in our tutorial, and we want to maintain a good resolution of our cables. So here we need a resample curve, and we need this cable resolution. We need also the geometry. Here we can drop this line for a moment and link this output here, but keep in mind, if I have these cables resolution, in this case I can set 32 and 3, you can see this, but if I increase the length of these, I want to increase the resolution in a proportional way. So to do this, we need to know the entire length of the curve. But keep in mind, don't use, in this case, the spline parameter, so not this length, because for the splines, as you can see, the distance along the entire curve. So if you have multiple curve in your object here in the outliner, you need to get the relative length, maximum length of each curve to pass in this resample curve, because this node works for each curve. So don't use this node, but use the length of the spline, and this node gives you the length of each spline and the point count of each spline. So if we have two curves here, one with 3 control points and one with 5 control points for each curve, you get the correct number of control points and the correct number of the maximum length. And this is the correct number to multiply with the cable's resolution before going in here in the resample curve node. I can select all these nodes, Ctrl J F2, curve resample, and this is very usable. Now we can add another integer number to manage the resolution of the single profile of the sub cable before instantiated on the main profile of the cable. So to do this, we can rename it in profile resolution, default 3, minimum of 3, and we can add a boolean attribute to choose what way we want. Use small, big, radius. So I connect these in a switch selection, I connect these in a switch. So because we have these two group nodes, we can enter in these get small and invert this output to have the same order of output from these groups. Now I need to add two other float values that are our small input radius from 0 and another for the big radius, and the environment will ignore one or the other depending on this checkbox. So if we want to use the small radius, I link these here, the small and the big here in these inputs. Now from this switch, if I want to use the small radius from this input and not in a calculated way, we want to have here for the big radius what the calculated value of the big, otherwise we want these, so the original big radius for the input. And if I duplicate these and connect the same checkbox, I want the same behavior for the small. So from here I have always the big radius calculated or by this input, and in this switch I have always in this output the small radius calculated or from the group input. So in this case, if I want to use the small here, I want to reuse the small radius of the group input, otherwise I want the calculated small values, because here I have in input the big radius. So in the false I want to have the calculated small radius. I can press H, select all these nodes, Ctrl J F2, choose radius mode. Now, because we are going to use this external cable count for the external part of the main cable, but we want to fill the entire cable with other cables inside, we need to calculate the number of the internal cables in a dynamic way based by the big radius of the main cable, the external layer of cables, and the small radius of the profile of the single sub-cable. And to do this, we can use the same approach of these formulas, inverting and moving these parameters. So based by these, for example, if I divide both of these sides by big R, we have small r divided by big R equal to sine pi divided by n. And if I want to move out this pi divided by n, this sine in this part is equivalent to the arc sine, so the inverted formula of the sine, and this will give me arc sine of r divided by big R equal to pi divided by n. And now if I multiply both of these sides by n and divide both of sides by this arc sine of r divided by the big R in a bad mathematical language, if I move n here and arc sine here, mathematics don't hate me, I have n equal to pi divided by the arc sine of small r divided by big R, and this is the third formula. And with this I can have here a math node with a division by what? The small radius. So here we have the output of the big and here we have the output of the small radius, so I need to divide these, so this small divided by the big radius. Next I need to calculate the arc sine, and next I need a divide value between pi and this result, and this can give me this number of resolution that we need to fill the inside part of the main cable by cables. So because this output needs to be an integer number, we need to calculate the floor value, not the ceiling. I can select all these nodes, Ctrl G, and I can rename and invert this input here because we need to have here the big radius and here the small radius. Keep in mind this is a division, so we can't have a zero value here because a number divided by zero is an infinite value. So to be sure to not have any issues, I suggest you to set here for the big radius a small value but not zero for the minimum value, 0.6 times zeros and 1, it is not zero. We can easily connect this floor to the group output and rename it in an integer type, the resolution h to collapse. Save the project, tap to exit from this group, and here we can rename this group in get resolution. And why this group? Because we need to use it to fill the external layer of subcables with other cables inside of it. Now that we have this information, we can try to show some result here on our curve. As your default environment and project, we need to use an instance on points. We need to use a curve circle for the main cable and a duplicated version for the subcable. So we need to use these on the points and these on the instances. This is obvious because we need to have the small profile on the presample curve of another circle profile. Now we can hide for a moment the annotation because we need to transform these main cables from the curve to mesh, link these new profile, but before these we need to realize instances because we don't need to have here instances, but we want to have profile curves. So now we can link these, and with the Shift Alt and click we can see the result linked to the group output. We can set the fill caps. So now from the main group input you can see the profile resolution that we need to use here for the sub cable resolution, and I can duplicate these and link for the instance the profile resolution here, and I need to increase these a little bit. And for the first external cable we can use the external cable counts here, so the number of the circles, the profile circles of the sub-cables that we need to instantiate on the main layer of the cable. And here we have the big radius here and the small radius here. Don't use these small radius and big radius because we chose the correct output of the big and small depending on this check here. So we need to use this output for the big and the small. Now I can check these, use a small radius for example, and increase the small radius, and you can see the result here without overlapping or collision effect. We can increase the cable resolution to have a more smoothed entire curve. We can increase the profile resolution to 16 for example, and if I increase or decrease the small radius, you can see the big radius of the main cable needs to be increased. It's obvious, otherwise I would have overlapping issues between all these sub-profile cables. But if I want to use the big radius, I need to turn off these and increase the big radius. And if I increase the big radius, you can see these changes the small radius in a dynamic way. Maintaining the same external cables count, I have 32 cables here. So if I want to maintain the big radius in a static way, I can change the number of the count of the cables. And if I want to use the small radius, if I change the number, you can see that the small radius has the same value, changing the number of the cables on the first layer. Now, if I isolate this instance on point for a moment with a shift control and click, press 7 to see these result here, and decrease for a moment these values to 8 for example, and if I join for a moment the main resampled curve with this result here and use this for the output, you can see this result. Now from this result I need to fill this part with other small cables and circles. So the problem is that here we need to have a minimum of this value that can ensure to have other instance of the same circle radius here inside without collision here. So if I delete for a moment these, you can see if I have from this to this point the big radius, so R, and here we have the small r, the small radius. If I scale these inside of these, I need to have a new r first with the same small radius. So to get these new r first for another resampled curve that I want to have here inside, and to instantiate other time the small radius, so the small profile, we need to calculate this new radius first. And what is this distance? Is the entire big radius, so this r minus 2 times what? The small radius. So this is r, and if I subtract another time the small radius, I have a correct point to be sure to be able to instantiate another time the small circle without collision and overlapping issues here, okay? And not only this, I need to recalculate this new big radius that is smaller than the previous, but also the new number of the control points to resample the new curve, because I can't have the same number of the main cables inside on this curve. It's impossible. I need to have a smaller number of instances. So to get this new resample value, I need to calculate the new number of not external but internal cables count. And for this we have this get resolution, because I can pass through this group node the new big radius calculated, this big R first, and the correct small radius. So knowing these informations, I can move this viewer here to let you see the result. I increase the external cable to have more space here inside this cable, because we will look next the central part of this entire workflow, where we can't use this layout, but we need to use only one profile or nothing, up to 3 for the minimum value of the instances that we can assign on our layer curve. We can name rename this as a layer. So this is the first layer, the second inside, the third, and so on. So now that we have this configuration, we can move this a little bit. And now, as described before, we need to use a duplication of this workflow to calculate this entire schema inside. So I can press Shift D for a moment. Next, we are going to create a group node to simplify this workflow. But for now, I duplicate these. As described before, we need to recalculate the R first. And for this, I need to use this big radius and link these to a subtract value, because we need to subtract 2 times the small radius. So I can link these, multiply these 2 times, link these here, and this is the new big radius to get the new resolution for the inside part of our workflow, maintaining the same small value. Now that we have the new resolution here, we can use this resolution for the new curve for the second layer before the instantiate on point for what? For the curve circle with the same profile resolution, but keep in mind we need to link the main radius here and the radius of the subcircle. So the radius of the sub-circle or cable is the same small radius here used in this get resolution. I can press H to collapse these 2 nodes. Okay, and for the big radius we need to use this new calculated radius, so the R first. Now if I link these to the geometry, you can see this new pattern, and if I join these with this main join geometry and link these to the viewer, you can see the correct new calculation of this circle without collision. And if I increase or decrease the number of the external cables, all works until this case where I set not 10 but 9. Yes, this is the example, because we have no control for the minimum value of this R first to avoid the internal collision, not the external from the previous layer, but from the layer itself. Okay, now in this time we have no control on this value, but we can see here, if I increase the space of the layout, this workflow, and because we need to reuse some of these nodes, I can drop this line that is the main cable, so this cable here from the join geometry, because we don't need it, so I can drop it. I can leave only the realized instances from the output of this instance on point, and because we need to reuse these with these new values again and again and again, you can see for the first layer we don't have these to subtract multiply values, so we need to change the big radius here, adding the small values multiplied by 2, because next we are going to create a subgroup node with all these nodes here. Okay, so we need to anticipate these 2 nodes outside the group node, because inside the group node it will change the big radius with these 2 nodes here. So for this reason I need to duplicate these. So here we have the output of the big radius, and we need to link these, not subtract, but add the value of the small radius multiplied by 2. Next, we can select all these nodes here, press Ctrl G to create a unique group that we can reuse multiple times, and we can rename these nodes a little bit. So the first input is the big radius from 0, the second is the small radius from 0. I need to move these here because we are going to look another part of these. So this is the profile resolution. I need to move these nodes a little bit and you will understand why. Okay, Ctrl H, perfect. Sorry, this is an error. I have here the big radius here and the small radius here. Okay, these are inverted, so the small goes here and goes here, multiplied by 2, and the big radius is here to calculate the new R first big radius, and using these, getting the new resolution to be used in the new sub-level of cables. Press Tab. This is the new group, but it is not finished. Now we can delete all these nodes because we have this entire group. We can drop these, press H here. I remember you, this is the big radius and this is the small radius. Here we have these two nodes. We can drop all these dots. We need to use this big radius, the small radius, and this is the first group. I can rename it in cables from small, big radius. Now, because we need to reuse this node multiple times because we want to have multiple layers of cables, we need to link to this group output not only the geometry result, but also the new big radius here and the small radius here. So I can move these a little bit, create other dots, rename these in big radius from 0 and this small radius. We can go out from this group node, we can duplicate this node, and now we can use the same geometry, join geometry output here to link this new output and link the previous big radius are first here, the previous, so the same small radius here, and you can see we have two layers. I can increase these, and if I duplicate another time these and link these to another join geometry from this join geometry and this linking this output big radius and this small using the same profile resolution, it's obvious from the group input, I have the third layer and so on. But now we have a problem, and the problem is that if we decrease the number of external cables a lot, we have problem of overlapping of the subcables. So if I increase to 32 the profile resolution, you can see this big issue, and we need to control the R, and I discovered that if we have the previous number of the external cable, and trust me, I tried to calculate the correct number if I don't have much radius here, the big radius, and I discovered that I can't have less than 3 subcables. The minimum is 1 and the next value needs to be 3. And not only these, I discovered that the minimum number of the external layer count of cables, in this case we have 1, 2, 3, 4, 5, 6, 7, and as you can see, if I have less than 6 external profile for the previous layer, for the external layer, I can't have circle inside. So if I set 12, for example, for the external, the second layer are 5 sub profiles, and here we can't have other profiles. So we need to have a sort of switching that don't give an output for the geometry. So here in this node we need the number of the resolution of the cable of the previous layer to be sure to know if we can instantiate other profiles inside. So for this we need to go inside these cables from a small big radius, and here in the group input we need to add another resolution that I move here to the top part, and I can set the main resolution minimum 0, and if the previous resolution is greater than or equal 6, I move this in a switch, and for the geometry I can have a geometry, otherwise we can't have more geometry in the output. And now I can link these to this geometry. All disappeared because we have no resolution here. In fact, if I go back out from this group node, we have 0 resolution, and for this reason we need to link for the first layer the original external cable resolution, and here we have the first layer. Next we can go inside this group and export in the group output here the new resolution based by the new R first and the small radius, the new big radius and the small radius. So here we have in the output the new resolution here. I can go out and I can link these here and these here, and as you can see here for the third layer I can't have any profile. If I increase the external cable to have a minimum of 6 profile to the second layer, I can have a minimum of some profile inside. Now, for the last part of this, we need to control the R first, but not in a mathematical way. We can ask if the new resolution or a resample curve value in the inner layer if is less than 3 or not. We want or not use one single profile. So let me explain. If I enter in this group and if I ask me if this resolution is less than 3, I don't want to use an entire complex instantiating workflow with this curve, but I need only this curve circle profile, only one sub profile. Shift Ctrl and D to maintain the linking of the attributes here, and if I use another switch operation here and link this result here, I need to use not this output but this output here. So if I have less than 3 resolution value here, I need to use this only profile. Otherwise, the correct number of cables to be calculated from this part of the workflow. And this is the new output here. And you can see all works, H and Y all works, because I tried step by step increasing the number of these values. And you can see in this case, I can only have 4 cables, and I discovered that if we have a small value of the resolution of this layer, we can't have a number of 3 cables without overlapping or collision issues. So for this reason, after tests, I discovered this result, and you can see if I increase or decrease the small radius, the effect doesn't change. So the mathematical relationship between all the profiles is the same, only in the case where I decrease these. So in this case, for example, you can't have 2 or 3 profile here without touching each other. Now that we have this entire workflow of this control of this group node, we can select all these nodes, Ctrl J F2 cables. We can select these 3 nodes, Ctrl J F2 1 cable, and because we have here false, we can move this realized instance to the end of the entire workflow. Some dots to have a better understanding of the layout. Okay, this is the final result of the group node. I can go out of this, and now from this configuration I can add here as many layers as I want. So here we have these 2 nodes that I can use in a Ctrl J F2 big radius, change it for first layer. This is the first node, this is the second. Now we need to use the correct input here in the curved mesh, because we need to use the resampled original curve mesh here, and for this I can move this a little bit, link the curve here and use this output of the join geometry here, dropping this view, and you can see the correct result in the viewport. And now I can move this a little bit, take this node, and this, Ctrl D, Ctrl D. Okay, now I created 10 layers, and if you want to leave a space inside of your main cables, you can drop the layers that you don't want to have. Now, after adding the 10 layers, the layers that you need, we can add a tilt feature on our curve. So I press Tab to enter in the edit mode, press G to increase, to move this point on this in the space. I extrude for a moment this curve, press A to select all, Shift D to duplicate in another curve, press G to move, and here we have 2 curves. I delete one control point to have a different total length of these curves. Now we can go here in the group input and add 2 other attributes. One is the option if you want to use a number for tilting based by the length of the curve or the factor parameter of the curves, and here we need to set a boolean attribute, factor length tilting, or simple tilt, another float value for the tilting, and with brackets we need rounds R and D instead of using degrees or radians. And last, we need a material to assign to our curve material. Now for the tilting is not so hard. Before the curve to mesh, we need to add our node to set the curve tilting here. Now we can import the group input node. We can link this vector length tilt in a switch where we can select the correct float value of what the spline parameter of each curve here, and we can set the factor if we have true value, otherwise we want the length. And for this we need to multiply this value by what? By a value multiplied by a map range based by this tilting. So you can see here we would speak in degrees, but if I link this value directly in this attribute, it works in radian. So we need to duplicate this mathematical node. We need to multiply these tilting rounds by what? By 2 multiply pi, so the entire number of radians for one single round. So if I have here one round, I have 2 multiplied by pi radians, so one entire round here. And if I multiply this value by the factor or the length, I have the correct tilting needed in this set curve tilt. Press H to collapse, H to collapse, Ctrl H here. We can select all these nodes, Ctrl J, F2, tilting. And now if I increase the tilting round to 1, for example, you can see I have no check here, so I'm working with the length of the tilt. So for the length of 1 unit, so this is 1 unit and this is 1 unit, I have from here to here, near this point, 1 round, one other round here, and so on. And if I want to speak in a factor language, if I set these, you can see for each curve I have 1 round from here to here and 1 round from here to here. Now I'm going to use the length, but I need to increase what? The cable resolution to 16, for example, to have a better visualization of this curve. I can decrease the tilting, and now we can go to the shading part of this tutorial. The shading part, we need the UV map as the other tutorial that we created before, and for this I remember you to use the capture attribute for the main curve and one for the profile. We can add the spline parameter to get the factor value for both of these curves, the main curve and the profile curves, that are all these sub-profile. Link this output to a combine XYZ to get the X, the U and the Y, so the V values of this vector. Now we can link these to the group output to get the correct UV map. And remember to set in the output attributes here a name to use in your shading editor, UV map, for example. And voila, each vertex has the UV map attribute here. Press H to collapse these. I can select all these nodes, Ctrl J, F2, UV map. Now for the shading part, we want to export from this layout all the information about the indexes of our sub cables and the main cables, so the layer, a random value for each sub cable and the unique index of each sub cable globally. So we want to save information like this, 0, 1, 2, 3, 4, etc. for each layer. We want to store the information of the layer, so we have 0, 0, 0 for all these sub cables. We have 1, 1, 1, 1 for all these sub cables, and the index of the layer, this is the third layer, so index 2 starting from 0. Next we want to save the unique index of all these cables globally, so starting from here, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 here, and 16 from these, 17 for these, 18 for these, etc. in a spiral way, if we can say. And last but not least, another information to set for each of these cables a random value from 0 to 1 for each of these cables. So 0.2 for these, 0.5, 1, 0.9, etc. for all these sub-cables. And if you watch the intro another time, you can see I showed the different information using a color ramp to let you understand what type of indexing we have for the different context. So for each layer we need a value, an integer value, that is the number of the layer. We need a store name attribute because we want to reuse this information in the shading editor, and we can set here a name of the attribute that we want to save for each element, for each sub-cable profile layer. We want to store each information for each spline and not for each point, because here we have curves. I remember you in this part of the layout we have curves, always curves, splines. So we need to link this geometry here and this geometry here to the output, drop these. We want to save the integer information of our layer, and in this case I have 0. I can select this node, press Ctrl G to create a subgroup, because we don't want only save the information of the layer. I have other attributes that I can delete from here. I need to save not only the layer, and you can see if I press tab to exit from these, I can rename this group in save cable info. I can drop this value to have here the ability to be able to manage this value as the layer. So I can enter in the group, rename the value in layer from 0 and set here 0 for the first layer. I can drop these manually. Now to save the information for each layer, for each sub cable of each layer, we need to know the entire number of indexes of each layer, so the resolution of each main curve here for the first layer, for the second, and for the third, and so on, because we don't want to save the information of 0, 1, 2, 3, 4, 5, etc., but we want to remap this sequential number always from 0 to 1. So to be able to do this, I need to have all the sequential number of the indexes and the entire number. So we have the resolution, that is 6, and next in the shading editor we are going to subtract from this number 1 to get 5, and we are going to divide each index by this number to get a number remapped from 0 to 1, because 0 divided by 5 is 0 and 5 divided by 5 is 1, and all the indexes stay in the middle. For this we need to go inside this new group input, add a new input here for the resolution integer value from 0. We need another time these duplicated nodes, link these here and link this here. We want to save layer cable count. We can rename it in layer cables count and link the resolution here in this socket. So in this way, for this case, we can link the resolution here in the resolution, and now we stored the information of the layer for each curve of only this layer and the resolution for each curve profiles of this layer. After this, to have the single number of the index for each curve, we need to duplicate another time these, link the geometry here and this output here to save what? To save the single index of each curve for each layer. So I want to save the index per layer, and for this the attribute is the index of the single curve that I can link directly inside this store name attribute. So here we have 0, 1, 2, 3, 4, 5 for the first string, and the total number of the resolution here, so 6 for example. For the second layer we have another time 0, 1, 2, 3, 4, 5, etc., and the total number based by this store name attribute node. We need to rename these in layer cable index because we are going to use this name attribute in the shading editor to create this map range, and this node is finished. We can press tab. Now, instead of using this node here outside of this cable from a small big radius, we can move this group node inside this group node. So I can drop this, go inside this node, and here near the group output add a save cable info group node, linking this here in the middle for the geometry, link the resolution here, and for the layer we need, it's obvious, a new input attribute for the entire group node here, and we can leave this name as is. I can add 2 dots here, one here, and one here. Press this node to go outside this group node, and you can see now I have the layer here. We need to only set the number of the layer for each of these group. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. But starting from 0, we have 10 layers totally. Now, for the same approach of the map range of the single indexes of the profile curves for each layer, we need to have the same remapping values for the indexes of the layers in relationship to the total number of the layers, and we need to calculate the total number of the layers. So we have two ways. One is to store a static value from the last layer adding 1, or we can calculate this from an attribute statistic node with a store named attribute here in between. When we want to save the maximum integer value here, we need to link this geometry here, and for each spline we want to get the name attribute named layer and save this information. So in this way I can get the maximum value of the layer that we stored before for all the subcables, and we save this information for each spline with a layers count. This is the total number of layers that we have here in a calculated way. So we can select all these nodes, Ctrl J F2, save total layer count. Now, because in this output we have a bunch of circle curves, so all these curves profile in a unique set of curves, we can store another time for each spline what the global index of each curve in this set. So if I add an index attribute, an index field here, and link this information here in the global cable index, we have the information of the blue values here. Okay, so the entire spiral numbers of the indexes. We can select all these nodes, Ctrl J F2, save global cable index, same for all curves. And what does it mean? It means that for all the curves, for this curve, I have an index starting from 0 to the final number of these profiles. And for this curve, I have another sequential number from 0 to the final number. So 0, 1, 2, 3 in blue color here, and the same 0, 1, 2, 3 for this curve. And as before, we need to remap this sequential number from 0 to 1. And for the same reason, we can store name attribute another time for each spline with an attribute statistic, getting from this geometry the value of the index. I don't need to add the attribute named in global cable index to get the maximum attribute statistic value here. I can reuse the same attribute of the index and link this max here for this integer and name this in global indexes count. And next we are going to divide these values by this value, Ctrl H. We can select all these nodes, Ctrl J F2, save global indexes count. I named in a bad way here, indexes, also here, same for all curves. Now, if we want to have a unique random value for each subcables for all the curves inside this unique Bezier curve or object in our outliner, we need to know this information. Here we have one curve and this is a second curve. So for each curve, I need to know the index of the curve. So I have 0 for the first curve and 1 for the second curve. For example, I have the global indexes of all these profile curves. So I have 0, 1, 2, 3, 4, 5. And imagine if we have only these 6 curve profiles for each of these main cable. And what we need is to have a unique increasing value from 0 to the maximum number of the profile curves, subcables. So in this case, I want to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we need to remap these from 0 to 1. Now, if we want to get this new sequence of the indexes, we can use this simple method. We can easily get the single index of each subcurve, so 0, 1, 2, 3, 4, 5 for this curve, and 0, 1, 2, 3, 4, 5 for this curve, and add what? The total number of the curves in our main cable, 6 in this case, so 6 multiplied by the number of the index of the main curve itself. So in this case I have 0 plus 6 multiplied by 0 equals 0, 1 plus etc. equal 1, and if I go to 5 I have 5. But when I go here, so if we have the second curve, I have another time 0 for the first index of the first curve plus 6 multiply the index of the second main curve, the second cable, so 1, and here we have 6, and for 1 we have 1 plus 6 multiplied by 1 is 7, and you can see here we have the correct new sequence, a unique sequence. From these we can get random values. Before I said that we want to remap these values in a range from 0 to 1 is not correct. We want to transform this sequence of unique number in random values in a range from 0 to 1. And now to solve this problem here, we need to move these UV map nodes a little bit, and here we need for these main cables and here for the inner circles inside of each layer, we need to capture what? The integer information for each spline, and in detail the index for each main curve. The same duplicated for this geometry. Link these here. Next we want to use these two informations. So here we have this sequence 0, 1, 2, 3, 4, 5 in a blue color. Okay, so keep in mind we are talking about the blue sequence, and here we have the sequence of the index of the main cable. So this is the first and this is the second, so we need to add from this number what? This value of the index, so 0 for the first values and then 1 and then 2 and so on. So this is a multiplication here, and here we need to know the total number of the subprofiles for each main cable, and in this case this value is this information, this max information, adding 1. So I can add 1 to this information here and use this, press H to collapse. Now from this output here I have values starting from 0 to the maximum number of all the curves for the entire environment of this object. I can link these in a white noise W value to get a random value in out here from 0 to 1, and this is unique because I have a unique integer number here, and this is the remapping values. We can select all these nodes, Ctrl J, to create random values for each cable, save the project, and now we can save this information for each point of the mesh, the final mesh, because here we are speaking in curves language, but here we have the final mesh. So here we can store a new name information, float value, because here we have a value from 0 to 1 for each point. I link these here and name it in random. Link these to the group output, press Ctrl J to save random values. We need to set the material, so we can add a set material node here, a group input another time, because we need to link this material here, this socket. Ctrl H, select all these nodes, Ctrl A F2, assign material, and stop. We finished the entire workflow for the modeling and the shading part of the geometry node system. Now we need to go to the shading editor, but before we need to set the material here, and for this we can go in the material properties, create a new material cable, and go in the modifiers and select for the material the cable material. Go in the shading editor, we can hide the annotation, and to better understand this approach we show you here the result of the color of the gradient that we want to get for the manipulation of the color or the parameter of our shader here in the top left part of the video. So in this case I need to add the two attributes because I want to show a gradient based by the layer. So this is the layer and this is the layers count, and if I divide the layer by the layer counts and link these in a base color, you can see these. Okay, why? Because we have the number of the layers starting from 0, so 0, 1, 2, and the layers count. So keep in mind this layers count is not 3 but 2, because in the geometry nodes here in this section to save the total layer count we have the max number of the layer. So 0, 1, 2, 2 is the max. So keep in mind the correct naming that I set here. So in this case I have a perfect gradient. If I increase to 64 this external cable, we have a correct gradient from the first layer to the last layer. If I press tab, I move this curve a little bit because next I want to show you the different colors for the random values, and we can select all these nodes, Ctrl G to create a group, press tab to exit another time, and we can rename it in layer from 0 to 1, and this is the first information. I decrease this a little bit because I have lots of cables resolution and profile resolutions. We can pass these in a color ramp and use not this RGB but the HSV, far from complete red value to the blue value. Link this to the color, and this is the gradient. I decrease these to 8 and 8 for these, and increase another time the number of external cables. Now next subgroup here, we want to have a radial increasing of the index, so all these circles can have the 0 index, 0 for the first layer, 0 for the second, 0 for the third, etc., and increase its number from 0 to 1. And to have this we need another time an attribute input, another time because we need to divide to remap the values in a range from 0 to 1, and from this we want the layer cable index. So here we want to have the layer cables count. So here we have the total number of cables for each layer. Here we have maybe 7 or 8, here 14, here in the external part we have 64 cables. Now from these we need to subtract 1, otherwise we can't have a range perfectly aligned from 0 to 1, and here we need to divide this value by this value, link this to the gradient, and this is the final result, a radiant distribution of the index for each main cable. Select all these nodes, Ctrl G, H to collapse, press tab, and we can rename this group in index each layer from 0 to 1. Next, we want the global index from 0 to 1 for all the subcurves for each main cable. So for this, I add another time the attribute, I duplicate these, and here we have the global cable index. Here we have the global indexes count, and if I divide these by this number and link these to the gradient, this is the final result. But you can see there is an error because I have not an information saved for each line, but maybe for each point, because I have here a little changing of the color. So in the geometry nodes, if I go here in the save global cable index and save global indexes count, you can see here we have an error. We need to set a spline parameter here because we need to save the information for each single spline of the sub cable. And now if I go in the shading, we have a better representation of the gradient because I have all the colors from this color to this color, but I have another issue, and this is because I have this join geometry sequence in a not correct creation from Blender. So if you have this bad result in the sequential ordering of the join geometry, the unique way to solve this problem is delete all these join geometry node, create a dot here, delete also these, and with the shift and control pressed, drag with the right button of the mouse these to join again all these nodes in a correct sequential order. So in this case and in this way I can get a correct sequential adding from the first sub profile to the last sub profile of the entire output, and this is very important. And you can see the correct colors gradient from red to blue. I can select all these nodes, Ctrl G to create a group, H to collapse, Tab to exit, and I can rename this group in global index from 0 to 1. The last group node is the random node, and this is easy because I need only the attribute named random, link this factor to this color ramp, and you can see I have a perfect randomized colors for each subcurve, but also with the different values between the curves of the same object of the outliner. I can select these, Ctrl G, tap to exit, press N, go in the group values and delete the color vector and alpha because we don't need it. Press Tab and we can rename this group node in random from 0 to 1. And now with this information we can delete for a moment these vertices. Now we can go into geometry nodes another time and transform this entire workflow from this geometry node modifier in a single node thanks to this fantastic move to nodes item in this menu. If I click this, all becomes in a node, and for the UV map we can decide if we want to use this in a store name attribute as before for the other information, or export these directly in the group output, give a name in the attribute, so I can export these, drop this information and rename it in UV map to get the same result. Now that I have this node that I can rename in cable of cables generator, I can use the same name here. And the good thing is that I can select this curve, duplicate these, and click this button if I want to use a different workflow of these geometry nodes. You can see these 0, 0, 2, and I can change this information. And in this case, if I want to separate this cable with another material, I can click on this button to create a unique new material for this new cable, select this from this menu here in the node, go in the shading editor and change what information I want to show on my new cable. Finally, as always, if I want to show the information about the UV map, you can easily use the attribute node, set the UV map attribute here. We have a vector, so we need to separate this information, shift, control and click to see the information of the x from 0 to 1 along all the curve, or shift, control and click to see each single factor from 0 to 1 for each cable, from 0 to 1 to the entire round. If you want to use this node in your project, you can just create your file, go to the file menu, using the link or the append menu, select this file as the reference or create the group node from scratch. And if you are using my file for the tutorial, go to the subfolder node tree after double clicking on the blend file and select the node called cable of cables generator, and you are ready to add this group node in your geometry node system. Thank you guys for watching this video. I hope you learned something from it. If you want to take a like, subscribe to my channel if you like what I am doing. You can download this project from my Gumroad page or create it from scratch. Leave a comment and see you to the next video. Bye.